Hello friend, welcome back to my channel. I am Krunal Upadhyay and this is my channel Crew Electech. Today we see AC circuit with the pure resistance. If in AC circuit only the resistance is there, then what's happening? All the details covered in this video. Let us see. Here resistance having the value of R connected directly to the AC supply, that is the voltage V equal to Vm sin omega t. When the resistance is connected, that time the current I flowing through the circuit. Now what is the value of I? That is given by I equal to V by R, that we know very well from the Ohm's law. Okay, now instead of V we can put the value V equal to Vm sin omega t. Okay, so in this equation only the sin omega t is variable, Vm by R that is the constant. Okay, so if you want to find the maximum value of current, then you can find at the current will be maximum when the omega t equal to pi by 2. In the sin omega t, if you put pi by 2, then it will become I equal to Vm by R, and that is the maximum value, because the sin fluctuating from 0 to 1 in our case, and when the sin omega t is 1, that time I equal to Vm by R, and that is the maximum value. So we can say that the I am equal to Vm by R. So the equation reduced to I equal to Im sin omega t. Here I am equal to Vm by R. Okay. Now this is the representation via the diagram. We see the voltage and current waveforms and its representation. This is the phasor diagram. Here there is no phasor difference between the voltage and current. So the voltage and current both are on the same line. Now the presence of resistance, due to the presence of resistance, the current is somewhat lesser than the voltage. That's why the length of current is lesser and the voltage having the larger length. Okay, and both are on the same line. That means there is no phasor difference, there is no angle difference between the voltage and current. Okay, this is for resistive circuit. If circuit containing only the resistance in AC, then there is no angle between the voltage and current. Okay, now let us see the how the current and voltage is formed. This is the waveform, voltage and current waveform for the purely resistive circuit. Both starting from 0, both maximize at the pi by 2, both again 0 at pi, and again the cycle is completed at the 2 pi. You can see. Okay, so if somewhat difference is there, then the current is somewhat behind or somewhat back to the voltage, but in this case both is started from 0, maximize at fixed place, and minimize again its place, fixed place. Okay, so there is no angle difference. So the maximum value that is given by the Vm for the voltage and the maximum value for the current, that is the Im. You can characterize this waveform by giving the equation. So this is the instantaneous equation. Just if you put down the value of omega t, that is the value of x-axis. Okay, so you can find the instantaneous value of that voltage by putting the value of omega t and Vm in the equation. Okay, so what is the calculation? How can you calculate the power in the pure resistive circuit? So normally the equation of power, that is the voltage into current, V into I, that gives the power. But in our case, again, that is the V into I, but just you have to put down the value, what is the voltage and what is the current. So in our case, the voltage is Vm sin omega t and the current is Im sin omega t. Okay, so its result at here, this is the P equal to Vm into Im sin square omega t. Okay, so next equation, instead of sin theta, you can write 1 minus cos 2 theta divided by 2. Okay, so the result, by calculating the final answer, you will get the equation of power, that is the Vm Im divided by 2 minus Vm Im divided by 2 into the cos omega t. Okay, so in this equation, the first part Vm Im divided by 2, that is the constant part. Okay, this value Vm, that is the maximum value, that's why this is the constant. This is the Im, that is the maximum value of current, that's why this is the constant. Okay, so the whole term of the power, that is the constant, and this term, that is the cos 2 omega t, that depends on the cosine value, that's why that is the variable. Okay, so the first part is constant and the second part is, that is the variable or the fluctuating. Here, that is the representation of power. We already see the waveform of voltage and current, how it's there. Now the power. Okay, so in the first half of the waveform, the voltage and current, you can see here. Okay, here the voltage and here the current, both having the positive value. Okay, so if you multiply the voltage and current in this region, you will get the positive value. Okay, that's why the power is positive in the first half. Now let us see in the second half. Here the current having the negative value and the voltage also having the negative value. So the multiplication of minus and minus results the plus. That's why the power is positive in second half. Okay, so in first half and second half, both having the positive value. So the power is positive. You can say that the power is positive in the pure resistive circuit. Okay, so let us calculate what is the average power in the pure R circuit. So if you want to take average over the cycle, then you have to integrate from 0 to pi. This is the value of power for the whole cycle, and that is given by the equation P equal to 1 divided by 2 pi. If you take integration for the whole cycle, then just you have to put down the value for that band. The band is starting from 0 to 2 pi, so you have to take 2 pi minus 0, and this is from 0 to 2 pi. Here the value of power integrated over this x-axis, that's why we putting the d theta here. Okay, now let us simplify it. Just you have to put down the value of voltage and current. Instead of power, you can put directly this value, then simplify it to the next, again next, and finally just you already see in the value of power what's happening. Okay, so now the 2 comes out, and the instead of 2 pi, here the 4 pi is there, and integration of 1, that is the theta, and limit, if you put limit, then it's 0 to 2 pi, and again it's integration of sine 2 theta, that is the, sorry, integration of cos 2 theta, that is the sine 2 theta. Okay, and that is minus. Okay, and already minus sign is there, that's why we are putting minus here, and again the limit, that is 0 to 2 pi. So if you put the limit first 2 pi, then minus 0, and same for here. Okay, so for the resultant of this, that is the 2 pi minus 0, and the whole value, if you put the 2 pi in the sine 2 theta, that is also 0. If you put 0, then that is also 0. That's why this whole part is becomes 0. So the power P equal to, that is the Vm Im divided by 4 pi into 2 pi. Finally, power P equal to Vm Im divided by 2. Okay, so instead of 2, you can write twice root 2 into root 2. Okay, that's why Vm upon root 2 and here Im upon root 2. Instead of Vm upon root 2, you can directly write the Vrms, and instead of Im upon root 2, you can write Irms. Okay, that's why the power in the pure resistive circuit, average power, okay, that is V into I, and V and I having the RMS value. So thank you very much, my dear friend. You can subscribe my channel by searching Crew Electech on the YouTube, and you will find these results, and just you have to click on the subscribe button and you will subscribe my channel, and you can see the video related to the triple I subject or the basic electrical subjects on my channel. So thank you very much. You can subscribe my channel. So this is up to the now. Thank you for watching my video. Keep watching and thank you.